Hello guys, here is a new video on optimal control with Matlab Simulink tutorial. In this video we will talk about optimal control for linear systems. So linear quadratic regulator for linear systems, LQR. So we have a system in open loop x dot equal ax plus bu, a linear system. Our objective is to find u such that we minimize a cost function j. This j is quadratic with respect to the state and to the control, and we have a quadratic term related to the final state. Q, R, and QF are positive symmetric matrices. Q is related to the state cost, R is related to the input cost, and QF for the final state cost. We can solve this optimization problem using a lot of methods. For example, we can use dynamic programming, we can use Lagrangian multipliers, we can use Hamiltonian and other methods. The steps, without going deeply in the details, are: we solve Riccati differential equation, which is given here in the box, and the optimal control is u opt that solve this equation. Let us return to our system. So here the usual system that we are using in this series of video, and our objective now is to find an LQR controller. We will try to understand also the effect of the choice of the matrix Q and R. So we will go to Matlab Simulink implementation. So again here I will start with the script. So linear quadratic regulator example. So initialization, I will put clear all, close all, and CLC as usual. I will put two percentage to have the title. System declaration, I will put A, B, C, and D. LQR, so here I will start with Q is identity 2 because we have two states, and R I will put 1 because I have only one input. LQR is a function of a Matlab that needs A, B, and Q and R. I will run the simulations and I will get the values of K and J, So I will put here a state space. I will put A, B, and identity to get the state outside the state space block. I will put again for the feed forward and for the feedback. I will put a step. I will put a comparator to compare the reference with the output. Here I will return the block. I will put K that I calculated using LQR, and here I will put a scope, put a mix to compare the reference with the output. So here I will put C. Here I will put the state. I will run the simulations, and as you will see here we have stabilization. Here, okay, it's better to see also the states. It's better to see the states and the input. So here you see the evolution of the states and the evolution of the input. Here it is the maximum value is 4. We have this behavior. I will change a little bit Q. I will put T and I. So here is the evolution of the states and the input, and we have stabilization. I will put a small value for R. So here you see the maximum value of U is 40. So it is related to the value we choose for R. I will change Q. For here I will put a small value for X2, and you see the evolution. Here also we have a changement and we have a stabilization of the system. For more information, please see the description. Thank you for watching. Bye bye.